All right. Well, in the interest of time, I'll get through my intro slides and then we can let George and Paul here get started with their presentation. Um, so welcome and thank you everyone for joining us. Today we will hear from George Williams, founder and CEO of Reliability X, and Paul Crocker, a senior reliability consultant at Reliability X, on the topic, what is reliability and why should you care? This webinar is brought to you by the Southwest Environmental Finance Center and Reliability X. We are reserving 5 to 7 minutes at the end of this webinar for questions. So please type them into the chat either during the webinar or at the end of the webinar, and I will also be monitoring the chat in case anyone has issues. So just a brief introduction, the Southwest Environmental Finance Center is part of the Environmental Finance Center Network. We provide training and technical assistance to small water and wastewater systems around the country. Here's a list of our other centers and common project partners. So this network was created by the EPA, and there is an environmental finance center in each EPA region, primarily based at universities. And each center specializes in different technical, managerial, and financial topics related to small water and wastewater systems. If you are interested in receiving free technical assistance, you can go to our website, efcnetwork.org. And on the top right of the screen, once you get there, you'll see a Get Help button that will lead you to a page to request assistance. And we're able to offer up to 20 hours of free assistance on a variety of technical, managerial, and financial topics. And so with that, I'd like to pass it off to George and Paul from Reliability X.
Excellent. Thank you so much. Let's just switch screens here. Hopefully everybody is seeing the screen. Hi, welcome, and thanks for joining us today. My name is George Williams. I'm the founder and CEO of a company called Reliability X. We're a consulting firm associated with maintenance and reliability practices. I have a master's degree in reliability engineering and a bunch of other fun accolades. So we'll let Paul introduce himself. He's way more important than I am. Go ahead, Paul.
I'm Paul Crocker. I've got the pleasure of working for Reliability X for the last 2.5 years. Prior to that, I spent 30 years in a big water and power utility in Kansas City, Kansas. That's kind of where I first was introduced to Heather as they were working on building the AMCAN work asset management program. So you can see all those sort of little certifications and stuff there. But at the end of the day, I love water, I love asset management, and working at Reliability X. So it's good stuff, and we hope to share some things on reliability with you today.
Awesome. Thanks, Paul.
Next slide. So reliability is defined as the probability a product, system, or service will perform its intended function adequately for a specific period of time or will operate in a defined environment without failure. And that's a definition from the American Society for Quality, or ASQ, as they're more commonly known. Management of reliability is the management of risk. So what's the definition of risk? Risk can be defined as the probability or likelihood of an event or situation occurring that may result in adverse consequences, harm, or negative outcomes. In everyday life, risk is often associated with uncertainty and potential loss, damage, or unexpected events. It involves addressing the possible outcomes, their likelihood, the potential for impact they may have on one's objectives, assets, or well-being. And managing risk typically involves identifying, analyzing, mitigating, or controlling potential risks to minimize their negative effects and make informed decisions. Sort of flip side of that is opportunity. So what does reliability really mean? So for customer satisfaction, that means no surprises for loss of city water to their home or business. Customers are well informed ahead of maintenance, the reason for the maintenance, and able to give input on the maintenance if it severely impacts their operation or health. Reduced operating costs, that can mean motors and gearboxes are laser aligned and run with fluids appropriate for their operating temperature, load, operating environment, and not just according to the manufacturer's recommendations. LED lamps are even used as appropriate to sometimes help reduce energy spends. Reduced chemical and energy spend. Chemical feed pumps are calibrated regularly. Leaks in the system and the distribution system are identified and corrected. Those leaks can cost a lot of money. I think last number I heard something like most systems have about 20 to 25% water leakage in their distribution system. So that's a huge impact on the plants. There's a lot of energy that goes into pumping and chemicals that get used on water just to get dumped in the ground. And fixing that has been a big endeavor for almost all utilities. Improve compliance. So that means like QA, QCs for analyzers are way of life, and it's done at intervals necessary to maintain compliance. Operating preparedness. That's like knowing distribution consistent system conditions when there's large community events like holidays, when the distribution or collection system maintenance happens ahead of time. So operators can make and plan for adjustments ahead of time. Also means lower insurance rates. So like risks of fire to the plant. So your fire suppression system and fire detection systems are up to date and gauges are measured and backflow preventers and things like that, or the maintenance is done on them at the right time and renewal and repair are done. Isolating transformers like firewalls between them to separate those two from each other, especially when they're close together, like there are in a lot of designs for redundancy. Separating those with firewall is nice, especially if there's a fire on one, it doesn't spread to the next. You have chemical containment. And then over time, even well-maintained assets will fail, but generally they don't fail immediately or unexpectedly. And so when PM compliance is high, there's less unexpected failures and fewer late night and evening call-ins. At the end of the day, it's about peace of mind. So reliability is really risk management. So for operations risk, something to think about is like my primary ferric chloride pump just failed. Did I know the backup ferric chloride pump was down for service? Safety risk. Did I know there was a chlorine leak before I went into the room to make a feed change? Have my chlorine leak detectors been bump tested? Quality risk. My effluent chlorine analyzer says we're in compliance. Have the operators been doing rounds to bench test our analyzers? Have we done QA QCs on all analyzers, and how do we know? Financial risk. Our operator says our high service pump one, which can produce 20 million gallons a day, is vibrating so badly it can feel it when it walks in the room. Did we know that condition beforehand? Did we have a plan to pull and repair it safely? Did we budget for renewal and replacement of that pump? And how quickly can we get it rebuilt? Environmental risk. We use aqua ammonia in our post-treatment. We store it outside in large tanks. Have those vacuum relief valves on the tanks been tested? Have the pressure relief valves been tested? Has the tank thickness been tested? How often has this been done? So there's other compliance risks and others. So those are just little examples of risk and things that need to be managed to mitigate those risks. Next slide, George.
Yeah, oftentimes in water utility plants, redundancy is built in to help mitigate that risk. And so mathematically, if we've got a couple of redundant pumps at, say, a 99% reliability individually, the system itself is now at 99.99. However, as soon as one of those redundant pumps fouls or is currently out of operation for maintenance, you've lost that redundancy and the risk is immediate. And so maintenance and reliability is not only about building in the redundancy to reduce the risk, but also managing the risk once that redundancy disappears. And so we'll kind of talk all about that. From an ANSI standpoint, the average, what they call mean time between failure, or the average lifespan in between some component fouling, whether it's a seal or a bearing or impeller wear, whatever the case may be, the average lifespan from an ANSI perspective is about 2.5 years. For organizations that are more reactive, meaning they kind of run their equipment to foul, that average is only 1.5 years. For organizations that are very proactive, they're actively utilizing either predictive technologies, and we'll talk a little bit about those in a couple of slides, or have very robust preventive maintenance strategies. Their average mean time between failure is 4.5 years. So you are 3 times more likely to have events if you are a reactive organization than if you are a proactive organization. And of course, each of those events have cost. In addition to just the risk of the organization from operational perspective, there's also a safety risk involved in being a reactive organization. What you see on the screen are 2 studies from independent sources. One is from a gentleman named Ron Moore, who's the author of Making Common Sense Common Practice and has been in many, many facilities to do studies. And most of where he's at is in the manufacturing space, but the same rules apply. The more reliable the plant is, the better the safety record and the lower the recordables are. On the right-hand side, we've got a study from 2000 from the American Society of Safety Engineers that looks at executing your PMs on time, a reduction in overall equipment downtime, and the impact that has on the safety record. And you'll see that all of those trend lines are going in the right direction, which is down. And so, this is a documented, quantifiable set of data that tells us that a reliable plant is a safe plant, and a reliable plant is a compliant plant. If we think about reactivity and proactivity in a little easier sense, in a more simpler terms, the difference between a Model T Ford that's currently rotting in the earth and one that's drivable and in pristine condition is not just how well the mechanic took care of it, but also how well the operator took care of it. So reliability is really about what are we doing physically with the asset? How are we interacting with the asset? How are we inspecting it? How are we maintaining it from a preventative maintenance perspective? What are all the activities that we do to help ensure its longevity of life and its risk mitigation factors associated with plant operations? We've really got 3 choices, and we'll dig a little deeper into some of this in the next couple of slides. But you can either spend too much and be incredibly reliable, but wasteful because we're spending too much. You can spend too little, at least your budget can say we're going to spend too little, and be very reactive and have excessive failures and have to rush order parts in. And what that leads to actually is more waste, because you're going to spend more than is necessary to keep the plant in operation. Or you can manage the risk appropriately between the risk event and the cost of mitigating that risk and be at the more optimal cost level. And so it's really just one of 3 things to do. We can spend too much and be really reliable. We can spend too little and be very reactive, in which case our costs go up. Or we can manage the risk appropriately and spend an optimal amount of money, have a good, clean plant, very compliant plant, and a very safe plant.
So, what's the difference? So a reactive environment will have basic PMs, often on things that shouldn't even be PM'd, like check lights, room lighting, limited inspections, not inspecting the right things, limited or no use of predictive technologies, or when they are used, training wasn't given adequately for those technologies. Not using laser alignment or precision maintenance techniques. You can do alignment even with dial indicators just as well as you can a laser alignment. Laser alignment just makes it a little more efficient. But if you haven't been trained the right techniques, or the last guy that was there kind of figured out a way to do it and showed you, and you're still experiencing failures or higher energy costs, often those alignments then aren't that effective. There can be catastrophic failure, cause other parts when a main component fails, like if there's a a problem with some switchgear. If it causes a fire, it often destroys things next to it and very expensive to fix. Spare parts are based on a hunch or a budget and not on actual criticality and use histories in the plant. Again, very little technical training. In extend to that, reactive is often unhappy operators, maintainers, customers, doing unnecessary PMs, not doing PMs because we didn't have the parts, not doing PMs because of the day of the week, Fridays. Critical spares are on hand and no idea of their availability. What training? No training. We don't have a training budget. It all sort of results in a terrible culture. So it's often a sort of a loop of doom for a plant and high costs. Where the proactive side is PMs are based on failure modes, inspections to find defects and remove them immediately take place. Use of predictive technologies to know beforehand happens. So use ultrasound or oil analysis to find conditions in the equipment without having to take the equipment offline to do those often. Use of precision techniques to ensure proper installation. Again, laser alignments, proper shimming techniques. Spare parts are based on math and based on criticality for the process in the plant. And robust training happens before tools get used and before maintenance happens and continues to happen. It's not just a one-time event. Proactivity also means happy customers, operators and maintainers. Unnecessary PMs are removed from the system. You're no longer just going out to check if something's there or not. Well, we used to see PMs that say check motor. Well, what does that mean? We've removed those sort of things from the system. Run to failure is a chosen strategy, and it's applied to some asset types where that makes sense, and where the criticality for that asset into the plant processes has been done. Critical spares are on hand, and we know their availability from the vendor and from our own stores. And as a whole, we love training and look forward to it, which all results in a great culture.
So the bottom line here is that we have to take care of our assets. Otherwise, the assets are going to manage us. You've got two choices. You can actively manage your assets, or your assets are going to manage your day-to-day operation. And so if in your head you think about the plan on a day-to-day basis, if each day there's a different emergency and somebody has to respond to that from a maintenance perspective, then the assets are managing you. They're managing the operation and they're deciding what you're going to do and what you're going to spend. In the inverse of that, when you're actively managing asset risk, there are technologies and human intervention ways to ensure that the asset is giving you a good health indicator. You're checking the condition of components that fail. Generally speaking, the asset as a whole is not what fails. The parts fail. And there are methods to assess the condition of those parts. Some of those parts are designed to wear out, like the brakes on your car. Some of those parts are designed to last a lot longer if you install them with precision, versus if they're not installed with precision and they just don't last as long. And so we have to actively manage through a strategy how to take care of each and every individualized asset so that we can be at the appropriate cost and have the appropriate level of risk in the organization. To sum this up, your assets have an attitude. Whether you like it or not, they don't care about your budget. They don't care about the board. They don't care if you're a small utility or a large utility. They don't really care if you have to go to a recital or a soccer game tonight. They're going to foul at the most inconvenient time. They just don't care about your desires. It's not about your desire. The board can say, I only want to spend X on maintenance, and you're still going to spend more. The reason you spend more and pull it out of another fund is because you didn't spend the appropriate amount of funding to keep the asset at a minimal cost. There's just not, when you buy it, you can buy a car, you either buy a Toyota Corolla or you can buy, I don't know, back in the day, a Yugo. They have a completely different expectation of reliability and a completely different expectation of cost to keep them operable. It is baked in, it is designed in, and you as the operator don't really get a choice. If you decide not to change the oil and the engine seizes, that's the choice you made. I guess you do get a choice, but it's about whether or not you're going to do the appropriate level of maintenance required for the design of the asset that you have. And if the choice is we're going to spend less, you will ultimately spend more. And that's just kind of how this works. And so the reliability is about understanding and coming to the conclusion of what the right spend is. Not too much, not too little. How do we manage the risk and keep the cost as low as possible?
So what do we have to do to be reliable? We can manage or predict failures and eliminate surprises. We can eliminate recurring issues, and I put some slides here on the issue that we had at the plant. So we had a combined clear well, and that's where we chose to pull our plant effluent sampling from. And we had a turbidimeter and chlorine analyzer and pH analyzer and temperature and everything else we kind of needed in that area. But we had 2 floors, and the bottom floor was where all the pumps and the piping were, and right above it was where the analyzers were. And the operators would make hourly rounds, the lab would make hourly or rounds as necessary to pull samples off of equipment. And generally that when they did that, water would get on the floor, it would end up dripping on the pipes below. And so over time, those pipes would build up a little calcium on them from the hard water. So we had an issue with the turbidity where all the filters were really nice and stable, well within where we wanted turbidity to be. And all of a sudden we'd see these giant spikes of turbidity. So much so the operators would come running down to see what was going on. I'd get a call from my office. I'd have to get a tech and mechanic. And this went on for years and years. We tried to figure out what it was. Got even some engineering firms to come in and help us. We eventually corrected the problem. But one thing we did find that was contributing to the problem was one of the glue joints wasn't glued. And you can see from the second picture from the left where I cut it off and taken a picture of it, there was no glue there. And you can see even more calcium efflorescence next to that. So I took another screenshot and put it on a piece of paper and logged that in the EAM system. And then the final one is where we cut that piece of plumbing out, made sure everything was glued and put it back in place with the union. So we eliminated that failure, and there were no more surprises with unexpected turbidity events that happen throughout the day or evening or weekends, that we completely eliminated that failure. So that was huge. And then the last one, prepare for future workforce with funded training, appropriate technologies, tools, lubrication best practices, laser alignment tools, ultrasound tools are an incredibly effective tool for water, wastewater environments, and for successful maintenance and cultural improvement for all.
That's still your slide there, Paul.
Did you go to the next one? For some reason, it dropped off my screen. Are you on the? Would you rather have?
Yes, sir.
Okay, so use of technology can give you an advance notice. If you haven't started anything at all ever, then lubrication analysis should be your first go-to, especially for equipment that has oil in it that you can pull samples from. That one's cheap and easy. It's $35. You send it to a lab. They do an analysis and give you some things to do to address what's seen, and that can get tracked and trended over time, so you can see how your efforts to correct those situations play out over time. Ultrasound for structure-borne and airborne is another great tool. It's easy to acquire, fairly inexpensive overall, easy to test and use, and it can be used on all kinds of things. We used it to find chlorine leaks on valves that we wouldn't have found any other way, tank thickness with ultrasonic thickness gauges, infrared thermography and vibration analysis, and motion amplification are some very advanced techniques only the very largest of plants can really afford to bring those in-house because they take specialized training and skill. Even though an infrared thermography seems simple, it's deceptively not simple. And it really requires somebody that's had training on using that. So for those things are things that you can outsource. And then performance testing on motors, you can do offline and online testing of motors. But to say all that too is don't forget to budget for annual tool training. Just think we train our operators, and maintenance is an extension of operations, and we need to be funding maintenance as training also.
All right, grab onto your seat. We're going to go through this quick, but you're going to get a good understanding of what we're talking about and how the maintenance organization can help reduce your current spend when it comes to maintenance. What you see on the screen is what's called the bathtub curve. It is a failure pattern curve of how parts fail. So for example, all the way on the left-hand side, we got what's called infant mortality. This means the part did not burn in. It failed due to poor installation. It was a warranty issue. It was made a day after Super Bowl. You name it. It just wasn't a quality part, and so it failed. All the way on the right-hand side, we have age-related wear out. This is when a part lasts its full expected life. So you're getting 10 years out of a bearing. These things are unicorns. They almost don't exist unless it was built in the 1940s. So there we have that. Everything in between is called random. It's a random event pattern. If I purchase two pumps, put them stand side by side and operate them the same way for the same number of hours, they are not going to fail on the same day from the same part failing. Just doesn't happen. Really, really low probability. That means all the events are random. If I take a grease gun and I don't wipe it off really good and I squeeze in a speck of contaminant into one of those pumps bearings, eventually that bearing is going to fail before the other bearings in the other pump. And so that's just the way it works. All of our assets are designed with a base expectation of reliability. So just like I said a couple slides ago, I've got a Toyota Corolla or I've got a Yugo, that line is somewhere else. The maintenance organization's role is to manage deterioration. So as the lubricant deteriorates, maintenance shows up and they relubricate and they restore back to base condition. As a belt wears, they inspect the belt, they replace the belt, restore back to base condition. This happens over and over and over again throughout the life of an asset. Maintenance's role is restore to base condition, protect the asset. The underside of this sawtooth pattern is the cost of running and maintaining the asset. As it deteriorates, my VFD ramps up and I use more energy, I lubricate, I restore back to base operating cost, and this sawtooth happens over and over and over again. The techniques such as designing something more robustly, we call that design for reliability, allows us to raise that expectation level because we're designing things to be more reliable. In addition to that, we create PMs based on actual failure modes and not OEM recommendations. You didn't walk around your car this morning. You didn't check all the tire pressures. You didn't check your fluid levels. You didn't check the left turn signal. You didn't do those things because, in terminology that we use, the risk priority number is low. Inside the cab, you've got a light that tells you that your tire pressure is low. Inside the cab, the blinker blinks faster, so you know it's out. There are what's called detectability methods. And so when we develop a PM strategy, we utilize techniques that address only the failure modes that create risk. And we address them appropriately. This means that our deterioration curve changes. We visit the assets less often, but we're still managing the risk appropriately. That lowers our base cost. We utilize the techniques like Paul was talking about because eventually this unit is going to fail. I put a contaminant into the bearing. Paul uses his ultrasound gun. He hears that this bearing now has a problem and he has plenty of time to plan the intervention. He can order the bearing ahead of time. It shows up on site. If we can't do without the asset, then it gets staged and it's ready to go for when it finally fails. If we can schedule it appropriately, we have plenty of time window to schedule it when it's least impactful to the operation. It's always impactful, but we want to schedule it when it's least impactful. Now, if we utilize our senses, I wait till I can smell the bearing burning, or I can hear it, or it's hot to the touch, we're too late. And that's why we become reactive. We're reactive because I just don't have enough time to properly plan it and get it done effectively. What's worse is when that bearing fouls, because I did not plan it ahead of time and take it down before the bearing blew apart, I have additional damage. So not only am I damaging the bearing, I'm damaging a shaft. I could impact the impeller. I could score the volute. I could do all kinds of things that now cost me thousands of dollars instead of what it would have cost to replace just the inboard bearing or outboard bearing or both. And so my costs go up when I have the catastrophic event, whereas when I'm proactive, my costs are minimal and I'm only replacing what needs to be replaced. For just a basic example of this is what we're looking at here. I can replace just the one bearing, or that bearing can have a completely reactive approach. And when it blows apart, the shaft gets scored, the volute is scored, the impeller gets worn and damaged, and now it's out of balance. Maybe the seal goes, and I've got all kinds of other costs. The common denominator here is that a reactive maintenance work order typically costs about 3 to 4 times what it costs to do a PM. And so if I am finding things with technologies, I will spend a third less in parts. That's significant. It's a huge, huge difference. This is an example of one of the other ways that you become reliable. It's eliminating recurring issues. This is an actual slide presented with one of our clients. This is on the wastewater side, and what you're seeing on the screen is a screen. Their air release valves kept plugging with grease, right? Which is a really common issue on the wastewater side of things. And so they very regularly would be taking these things apart to clean all the grease out and putting them back in over and over and over again all year long. We help them with what's called a root cause analysis. Why are they plugging up? We worked with their team to redesign. Well, I say redesign, but they bought like a $5 screen at Home Depot and put it on the bottom of these valves. And they have cut out the volume of rebuilds by about 80%. So much so that they went back to the valve manufacturer, and the valve manufacturer is trying to figure out a way to incorporate a screen in the design so that the rest of their clients don't have to have this issue. Finding recurring issues and making recurring issues disappear is another way to become reliable. And there's a bunch of examples here that I'll let you read through. I'm not going to read bullet point for bullet point. And I'm sure, Paul, you've got examples of doing this on the water side. Why don't you give us one of those, Paul? You got to turn off mute.
Yeah, so one of them I was thinking of is using, we had a big motor failures. We had a lot of vertical turbine pumps, and the ones for our raw water that fed the plant, we had 8 of them, and we had them between 4 each of our horizontal collector wells. They had 500 horse vertical motors that sat on top of a pump. I think the new motor price was around $150,000, $200,000. And then they sat on a pump that went down into the caisson, and that pump was, I believe, around $500,000 to $1 million each. Motor failures were being caused by several different factors. We eventually got those tied down, but even in doing that, one of the things we found is using those predictive technologies, ultrasound, and oil analysis gave us some great heads up as to what was coming. And in one case, we found a, uh, a, evidence of fluting on some opposite drive-in bearings, which were the largest bearings in these motors. And when they would fail, it's usually a $20,000 repair just to pull the whole motor apart and replace the bearings. Well, we did the ultrasound, and we could start to see more energy being used over time. Oil analysis, we'd go from like no parts per million of iron to 5 and 10. But I kept checking these for ultrasound changes, and it seemed to be fairly steady. There wasn't a lot of increase. So all we did is we employed some filter units to clean that oil back up, and we continued to track and trend this. We eventually started doing quarterly vibration analysis on it. But from the point where that damage, we first saw that to where we had to take action and planned action and pull and rebuild it, was like 2.5 to 3 years. So, if you can eliminate some failures, great. You can't always eliminate them on some big, heavy equipment, but you can certainly mitigate those. And if you use technologies correctly, it buys you a lot of time and heads up to where you can safely plan for rebuilding and even budget that well ahead of time. So you're not stuck in, oh, hey, this thing was vibrating off the wall. What do we do now? And that's not something that any of us want to be in.
You might even be able to capitalize that cost, right? Because
Right.
extending the life of the asset. So instead of it just being an expense because the thing fouled and somehow you've got to find the money, even the repair, because you're extending the life potentially, depending on your municipality and your finance department, you might be able to capitalize that.
Yep.
So what's next? So, oh man, the third thing we got to take a look at is the skilled labor shortage. This is significant today. Right now, there's a significant shortage of skilled labor across the entire United States. And while longevity typically in utilities has not been an issue, eventually the folks that are there are going to retire or maybe even get promoted. And the people that are going to replace them don't quite have the skill set of the folks that you may currently have. This is not a guess. This is not an opinion. This is reality. This is from an organization called Scientific Management. And Scientific Management has a mechanical aptitude test. And they will come into your organization, and you can even become qualified to give this test so that when you hire folks, you can give them a mechanical aptitude test. But they have tracked every score from everyone who's ever taken this test from 1971 until today. And since about 1995, the average score has more than cut in half. So what used to be an average of 60, 65% is now an average of about 20 to 25%. That means the people that are replacing the current generation can barely fix a sandwich. I don't know how they're going to fix major pieces of equipment. And so we have to prepare for this. Not only do we have to train people to try to close this gap, but we also have to try to reduce the level of expertise required to take care of some of our assets. And so, the operation and how they inspect things, and your SCADA or your Delta V systems or whatever system you may be running becomes even more critical to give you an early warning and heads up, especially for assets where you may outsource the repair because you don't have the internal labor to do it yourself. They may have a higher expertise level than we have internally, but B, you want to give them a nice advance notice, get the parts ordered in. If it's a rush job, you're going to pay through the nose. And so knowing things ahead of time is significant, but also training our people is going to be really significant as we move forward. Which is why it's really critical for us to start capturing tribal knowledge. if in the past you felt that the CMMS system, the computerized maintenance management system, or the system that you may use to write work orders and track your assets and have your PMs come out was not really that important, you might want to change your mind really fast, because this is the system that tracks the tribal knowledge. This is the system where you document how to do something to the asset and how you track costs, and at least from a maintenance perspective on the asset. And so today, if the tribal knowledge is going to disappear, this system becomes more and more critical to house the information that you need to manage and take care of the asset, and to train your people on how to execute work against the asset. Really, really critical step here in helping to transition tribal knowledge and ensure that the impact of losing skilled labor, at least for your facility, is less.
And on to that, I experienced that when I worked at the utility. Under me, I had 3 mechanics. Each of those mechanics had between 30 and 40 years of experience and training behind them. All of them actually had come from power plants and nuclear navy and all sorts of other stuff. They were really, really good mechanics. Unfortunately, though, they were all over 55. And when the first one retired, the next 2 retired within the year of that first guy retiring. So I lost all 3 of my mechanics in 1 year. So we had operators that had some maintenance experience that they got while they were in their previous water operating systems before they came to us. And I got all 3 of those guys for my maintenance staff. And so just compare having 3 guys with 40 years of experience each to getting 3 new guys, all with less than 4 years experience each. And they really hadn't had any maintenance experience in the plant, and unless they were operators before and watching maintenance fix something or starting or stopping something so they could work on things. Just think of the risk that increases because of that change in staff. And we were a big utility. We didn't really have availability to onboard somebody, in enough time to cover those retirements. And a lot of the times those retirements are like, hey, I'm retiring, I'm over 55. I'm giving you my month's heads up, so you don't really get a lot of chance to plan. But that increases a lot of risks inside our industry. And we're an industry that likes to stay out of the news. We don't like to go out there and say, hey, these are all the great things we're doing so you can have cheap water. And we can't raise our rates, but we just can't. So that's just one area that I think all utilities, big and small, really need to think a lot about, both for their operations and for their maintenance. Anyway, so in conclusion, reliability will save you money over time. It's not always inexpensive up front. Sometimes there's cost to it up front, especially if you buy tools and training. That does cost some money to do that. Knowing impending failure lowers your risk. Being proactive improves your safety. If you can plan a job, have all the parts there, have all the rigging there, have scaffolding there, whatever you need, have that all there ahead of time. Have time to go through the work and talk it over with operations and everything you need to do. Suddenly that work is a lot safer, other than, oh, this thing just broke, we all hands on deck to get it fixed. That's like the worst case. You really don't want to be in those situations. Eliminating recurring failures saves time and money. We saw it again and again at the point I was at. And then so much so that by the time I left, I think we were probably around 80 or 90% of our work was PM or PDM related work. Very little unexpected or corrective maintenance would occur for us. And being prepared for skilled labor shortage by capturing knowledge and training staff reduces your risk.
Wow, Paul. And then you left, so they've really,
Right.
really
Yeah, there wasn't a lot of heads up for them for that either.
Yeah, I'm wondering what, if they all left because of their supervisor, or did they all leave?
Well, it was because of supervision, but
kidding.
it wasn't because of direct supervisions.
So it's incredibly critical. So yeah. So in conclusion, Paul, what do you got?
Well, just learn more about this stuff. I think we're going to be doing some more webinars, hopefully with the FCN network over there. We're going to be doing a bunch of webinars through our organization, and we're on LinkedIn and other places. So just follow us, become more knowledgeable. I'm in AWWAs. I'm in two of the technical committees, the asset management, and the other one is the maintenance and reliability committee. We've been very active in both of those. So both those committees are doing good. We've got some stuff planned for ACE this year and some good sessions for those. So if you'll be at ACE this year or any of the other water conferences where those committees have got some content, those are always great. There's a lot of organizations out there that focus on maintenance and reliability. Society for Maintenance and Reliability Professionals is another great one where you can learn about these things. I learned a lot going to those conferences. Training, a lot of people offer training. You can learn more about the Integrated Asset Management Framework at University of New Mexico's Environmental Finance Center. That AMCAN Work Asset Management program is there. You can also sort of self-score yourself and see where you're at, kind of on an asset management perspective. And then you can learn more about us too at reliabilityx.com.
Awesome, Paul. Thank you so much. So that kind of wraps up our session. We want to both thank you for your time today. We recognize that that you've got critical roles at your facility and that your time is valuable. So the fact that you chose to spend a little bit of it with us is incredibly generous of you. So we appreciate that. We've got lots of questions, Paul. So let's start knocking some of these out. What's the biggest misconception about maintenance and reliability?
Maintenance owns reliability.
I think that's a great, you're 1,000% right. One of the things that's the hardest to do is to get operations to believe they own the asset. And the maintenance of the asset, right? The roofer doesn't come to your house and jump up on the roof and start ripping your shingles off and say, well, you were due. You own the asset. You decide if the roof is going to get replaced and the risk you're willing to take, whether you wait till it leaks or you fix it, you get it done preemptively. Maintenance's role is to convey risk. The roofer comes and says, hey, I see your roof is really bad. Like maybe you want to replace it. They don't just start ripping it off. Operations owns the asset. They own the acceptance of risk. Maintenance's role is to execute the work appropriately and to convey risk. Let's see. Would align the best practice to log and track all of these into your CMMS? Yes. Everything should go into the CMMS. Everything should be a work order. If you would like the engineering department to have easier return on investment calculations, then you have to have the costs in the system. It's not about tracking people's time. It's about tracking cost. You need everything in the system to know that pump A costs more than pump B, and here's why. It's got a terrible history of reliability. It could be located closer to something that vibrates a lot. There's a lot of reasons why you could have more unreliability at a specific asset, but if engineering and project management is going to replace an asset, it'd be nice for them to understand what the costs have been so they can develop an ROI. Presentation is being recorded. Let's see. We're a tiny town, 8-year-old waste treatment plant. It's been run with minimal headcount, no maintenance. Where should I start? I have a lot of other follow-up questions here, but initially the starting point is, are the assets even documented? Are they in a system? Have you done a criticality analysis? Where I would start, is to stop any bleeding. I don't know what your scenario is. You can ping us at ask@reliabilityx.com. We'll be happy to sit down with you and kind of have a half hour, 1 hour conversation and give you some free advice. But generally speaking, if you're starting greenfield, it's capture the asset hierarchy, understand your criticality, figure out, I like to explain it like this. What do I own? How critical is it? If it's critical, how does it fail? And what am I going to do about it? If you answer those 4 questions, you got a good starting point. Let's see.
And Heather would always ask, what do you have? Where is it? Who did you buy it from? How long ago did you buy it? Where are the manuals? Where are the drawings? Do you know where those are at? Does anybody know? Sometimes, I mean, I know some situations, even in the plants I've worked at, where people really didn't know. And it was an exercise by 10, 15 people to hunt down an asset or a valve or something because nobody had been recording it. And the people that did know are gone and they took that knowledge with them. So again, it's important to have that knowledge capture in place.
Yeah, and there's a couple of comments here, non-questions from Stephen. You're absolutely right. Not only when people were raised on farms did they have to do repairs, and so they were more mechanically inclined, but your father taught you how to do an oil change. You knew how to change the tires. You could actually work on a car. And so those days are few and far between here. So and then there's another comment that says perhaps we need to interview the older workers and ask them for their insights on different tasks. Yeah, so this is always a point of contention, right? They don't want to see a job plan come out of the CMMS system with all the tasks because they know what to do. They also don't want to, in some cases, don't want to tell you all that information because they feel like you're trying to take it away from them. And so it is important to capture that tribal knowledge, but do it respectfully. Explain to them why you're trying to capture that, why they'll see it coming out of the CMMS. It's not necessarily for them. It's so you can teach the future.
And there's one I was just thinking about. I failed a lot to do this and had a lot of opportunity. And from what I see in the comments here, it looks like there's a lot of opportunity. Capture the costs of those repairs. Capture the cost, capture the interval when they happen. Every time a pump fails, how many people were on it? What impact did it have on the operation? It may just be anecdotal. Write it down. Capture the cost of the parts, capture how many people worked on it, how long they took to work on it. Those are your tools that you can take back to management and say, look, you're blaming us for these failures when really as an organization, we're not taking the care of them that they require. And this is what it's costing us. If we put the right training and the right effort into this program, we can improve this so these situations don't happen. You got to record the data. Without it, it's just an opinion. Opinions don't really hold much weight with management.
And so just to piggyback on that, Paul, it doesn't matter if the opinion is management. The asset doesn't care. The asset doesn't care that your leadership team wants to spend X. You are going to spend precisely the amount the asset decides. And you will either do that by being proactive and keeping the cost down as much as possible, or being reactive and spending the maximum you could possibly spend managing the asset. There's not a lot of other choices. It doesn't care about your wishes. It doesn't care. Just doesn't care. It doesn't care who approved the budget. Like, doesn't matter.
Yep.
You've got to manage the asset if you want to spend less. So it's an investment. You have to invest in being reliable.
And I was just a maintenance supervisor. That was the highest level I had at the plant. And obviously I had more responsibilities as a class 4 operator. I had weekend duty. Oftentimes I had, control of the operations, maintenance, and lab for periods of time where people were on vacation. But one thing I always struggled with was getting buy-in by upper management. Like, you know, we need to be more reliable. And I would always get a sort of deer in the headlights look, well, we're redundant. I'm like, well, it's not the same thing. And it took a lot of work. Eventually I'd show up at board meetings, I'd talk to board members, I'd get them educated on things. And we ended up making a lot of progress towards stuff, even using SRF funds to improve our utility and do projects and stuff because we were doing asset management where we were being reliable with the plant. We could prove it. We also had lower insurance rates because of the things that we were doing. So all that stuff is everything that I did in the time that I had at the plant. And another example I have is a recent client engagement where I worked with a nuclear utility. And you talk about people that take reliability and safety to the max. Like there's a procedure for everything. If you got a common light switch, there's a procedure and they have to follow that procedure line by line. They can't just say, oh, I've changed out 1,000 light switches and just go do it. Don't find themselves out of a job. But one thing they don't really record on their work orders is labor hours. And they do that through some other means, but they want to convey that the cost for the work is valuable in the parts cost. So they don't put the cost in with the labor on the work orders. It's a little bit strange, but it's important to people when they start recording the costs, don't look at some of those things and beat people over the head of it, because maintenance costs are what they are. The only thing you can really do is become more reliable, and hopefully some of those unexpected costs go away.
No doubt. And for, just to wrap up, because we got to wrap up here, the fact that Paul was able to impact reliability at a major municipality from the supervisory seat should be your call to action, that there's no excuse. And I'm trying to say that as politely as Paul is my hero, because as a supervisor, he single-handedly took that entire, BPU down the path of reliability, getting approval for the tools and the training and implementing practices and showing results and adding value and saving money and reducing risk and improving safety. And he did that from the supervisor level. And not to knock that, but we also all know how hard that is sometimes to push the boulder uphill. And Paul did it every day, each and every day. And for that reason, and I've said this 1,000 times at many public events, this guy, he's my hero. He knows how to impact and affect change from anywhere in the organization. And that's what this is all about. How do you educate people enough to get them to realize that there's value to be had?
Absolutely. I think there's a lot of good comments and stuff here. Guys, thank you for adding the questions and stuff. And if you have more questions too, you can always email EFCN and submit them those ways, or ask at reliabilityx.com. We'll always answer back. But yeah, at the end of the day, you can improve your environment and improve the culture around you. And it just takes get in and do it. You don't always have to think too hard about it. You don't have to get a committee together and say, hey, can I lead in this? You just do it. And that's kind of been the way I approach things.
Awesome. Thank you all for your time.
Yep. Thank you.